Continuing lesson 4.5 on graphing trigonometric functions, sine and cosine. In your notes, I mentioned graphing variations of y equals the sine of x, and the step-by-step process can be found on page 580 of your book, but I'm going to try to simplify this a little bit for you. Let's take a look at y equals 4 times the sine of x. The amplitude is 4. So whatever number you have written in front of the word sine is the amplitude. Let me show you what that means on the parent function. The amplitude is just the distance from here to here. So the parent function has an amplitude of 1. And that's why there's no coefficient here, because it's implied that it would be a 1. So in this case, the amplitude's going to be 4. The period is going to be 2 pi. As long as you just have x here and you don't have a number that you're multiplying by x or dividing by x right here, it will keep the same period as the parent. So basically it's going to look just like the parent. The parent function, the sine of 0 was 0, but the parent function only went up to 1. This one, when you're at pi over 2, instead of going to 1, you're going to go up to 4. In the parent function, the sine of pi was at 0, so you're going to go to 0. The sine of 3 pi over 2 in the parent function was negative 1. So because we had an amplitude adjustment, it's going to go to negative 4. And then it goes back to 2 pi. And then you can continue the pattern if you wish. With something like y equals 2 times the sine of 1/4 x, the amplitude is now 2. And to get the period, you always take 2 pi, which is the period of the parent function, and you're going to divide by the coefficient of x. So dividing by 1/4 is the same as multiplying by 4. I now have a period of 8 pi. So for this graph, I'm going to start at 0, 0, like I did with the parent function. And notice my numbers here are a lot different. What I want to do is be able to do the same thing that I did here. I went up, down, up before I repeat the wave pattern. So I want to be able to do that same up, down, up, but instead of finishing at 2 pi, I have to adjust it to finish at 8 pi. So I put my starting point here, my finishing point at 8 pi, because that was the period, cut it in half, that gives me the middle point at 4 pi, cut this in half, 2 pi, that gives me the maximum point, which is at 2 because I changed the amplitude to 2, and then go halfway between these 2 points, which would be 6 pi, would give me the minimum point at negative 2. Now if I have something like graph y equals negative 2 sine of pi x, the amplitude is the absolute value of the coefficient of sine. So the absolute value of negative 2 is 2. So it has the same amplitude as this. But the negative is going to mean something different. So I'll show you that in a minute, how that pertains to the graph. The period, start with 2 pi because that's the period of the parent function. Divide by the coefficient. When I do that, I get a period of 2. So when I go over here to make my graph, I still want to start at 0, 0 because the parent function starts at 0, 0. A period of 2 tells me I should be finished when this gets to 2. So I labeled my x-axis from 0 to 2, and then I cut it in half, and then I cut it in half again, and I cut this in half. Now notice I didn't go up, down, up like the parent function does, like these functions also did, and that's because of the negative. The negative means I'm going to flip it and do the opposite. So instead of going up, I'm going to go down, up, down. And so basically, once you get the period, you put in your starting point, your finishing point, halfway between that should be another x-intercept. Halfway between that is going to be a minimum point if your coefficient was negative, and then it would be a maximum if your coefficient is positive. And so that's how I went down and then up and then finished.